In the future, fluctuations in electrical power input will increase substantially due to the expansion of environmentally friendly wind power. RWE and its partners are responding to this challenge and developing ADELE, an adiabatic compressed air reservoir for use in generating electricity. The following animation shows how this project works. Where does the electricity go when there isn't enough demand for it? ADELE can store it. This system works just like a huge battery that temporarily stores the energy in the form of compressed air. It all begins with an electrically driven compressor. Normal ambient air is compressed to around 70 bar. This is about 35 times the pressure of a car tire. Heat is generated in the same way as an air pump, around 600 degrees Celsius with ADELE. The innovation: this heat energy is not wasted, but rather put to use in an efficient manner. The hot air is forwarded to large heat accumulators that are pressure tight and well insulated, so they are able to store the precious energy for a long time without incurring appreciable losses. The compressed air inside the accumulator flows through a branched network of pipes through ceramic materials, thereby transferring its heat to them. Next, the compressed air that has cooled down considerably is passed on to an underground salt cavern, a huge natural cavity. Salt caverns have been used for decades as storage reservoirs for natural gas, for instance. This is where the compressed air is stored until it is needed again. When the demand for power changes and more electricity is needed, or the weather changes and calm conditions cause the wind turbines to stop turning, ADELE can fill in reliably on short notice. The compressed air inside the caverns that has cooled down to around 40 degrees Celsius is released once again. The flow moves towards the turbine under high pressure. To ensure that it doesn't freeze, which would normally happen, it needs to be heated up inside the heat accumulator. From here, the air flows to the turbine and rotates its blades. The generator that produces the electricity is connected to the turbine. The electricity flows into the grid for a short time and thus contributes towards a reliable power supply. ADELE is thus an ideal puffer and a flexible partner for expanding the use of renewable energy.